Hey everyone, my name is Grant Paul. Currently work on Facebook, at Ionogon, at Twitter, and I'm a valid and fan of Google+. I absolutely love sharing on it. No, I'm sorry. I actually really like Twitter and I really like Facebook. I'm also Canadian, and I clearly have way too much time on my hands. I love dabbling in iOS whenever I get the opportunity, and apparently I'm taller than Master Chief. Also, this is the first time using a headset like this. I've always wanted to be using it. I'm typically really awkward up here, just like talking on a computer and talking to the mics, but now I can walk around and still be awkward. So, anyways, bit of history about me. So way back when the iPhone first started, I started checking out Cydia. I was a huge fan of the platform, and it really allowed me to learn how Objective-C and the actual iPhone worked. It also allowed me to dick around with a few apps that I had the opportunity to rest with. For example, Chatheads on iOS. I was one of the first to break it out of the Facebook app and allow you to use it anywhere you want in the system. This is akin to the same implementation on Android, and I was able to manipulate it as I see fit. Also, one of my current projects, Ignition, is taking the Apple's CarPlay interface and putting it directly onto an iPad. So you don't need to plug in your phone or anything like that in the car. The car doesn't have to support CarPlay. You just plug in your iPad and it works. It's currently broken because Apple changed a bunch, but I will be fixing that soon. Also, in recent developments, I was one of the first, along with Stephen Troughton-Smith, to have native Apple Watch apps running on the watch. But they are also native, and they run UIKit, like proper UIKit. And I'm not going to talk about that today. That's tomorrow. So you should come for the lightning talks. So, on to other things. Let's talk curves. Curves are interesting. There's lots of types of curves. There's the Sega Genesis fake physics curves from Sonic the Hedgehog, if you recall about that. There's some mathematical curves. There's y equals 1 over x. You must know that from math. There's even Gandalf saying, no, you can't pass. There's the literal Coco curve type with a UI Bezier path. And well, it's actually a C-type. If you really think about it, you use a CG path ref, it's a curve. Anyways, what I'm talking about is thinking outside the curve. Let's ask Siri. Siri, what's getting ahead of the curve? I don't know, but I found these web results for you. Typical answer. Now, looking up what is a curve on the internet, you get ahead of the curve. It's being ahead of current trends or thinking. Some examples. Loops, Sonic the Hedgehog. He runs faster than basically everything on the planet. He's ahead of the curve all the time. Gotta go fast. Apple is ahead of the curve. Samsung is not. They're always playing catch up. Auto layout is I'm not starting a flame war. Even smileys are curves. So here's a picture example of a typical curve that you'd see where somebody's in the lead and somebody's falling scarcely behind. In this case, BlackBerry is falling so far behind, they're not even on the graph entirely. And well, Google doesn't even know what to call itself, so it's going to go somewhere in the middle. Advanced prototypes. So if you remember watching the very first iPhone keynote, they showed off this Maps prototype, this Maps interface that was totally revolutionary. It was a split pane in an iPhone app. The screen already doesn't have enough space to show everything, but they decided to split it in half. That was a prototype. It never shipped. But we can make really cool prototypes like this, and why don't we? At WWDC a couple years back, they had a talk on advanced prototyping. And it was from their prototyping team. They were saying basically things like, you can use Keynote to do really awesome things and use Magic Move. They don't actually do that. But they did coin the term fake it till you make it. But in my eyes, why don't you just make it? There's a lot of tools coming out nowadays. There's Form, Origami, Quartz, Framer.js. There's so many. And apparently, all of these really like blue icons. But they're a way for designers to design apps and create them just like with the simplicity of dragging and dropping things. Now, I like that, and I tried Quartz, and it was interesting, but it didn't work for me because I don't like dragging and dropping. I like typing. I program. I'm not a very good designer. I don't know how to Photoshop. It's hard. Also, on working with designers, never say no to a specific prototype or design. Hey, that's not supposed to happen. That's not physically possible is not a term that you as an engineer are allowed to say. It's actually detrimental when you say, I can't do that. Why can't you do that? No, it's because it's difficult. A difficult animation to implement is not something that's impossible. Now, sometimes it is physically impossible, like running like 40 blurs on screen at the same time, and like it just drops frames like forever. But hard does not equal impossible. If it's actually impossible, make it less impossible. However, if it's Android, it's already impossible. Now, personally, I prefer Xcode and hacks. This is the Clang Dragon. This is the original logo that Apple released one year when they talked about Clang as being the new front-end compiler. It's typically a better logo than Xcode itself, I think. But anyway, some tricks of the trade. There's Class Dump, there's Atom and Sublime as your standard editors, there's Hopper. Hopper is one of my favorite apps, and although that's not the typical icon, it looks awesome. So let's talk about those. Well, so Class Dump, it dumps classes. It takes whatever binary you throw at it and tries to find as many Objective-C classes as possible and spits out everything it can figure out about them. Sometimes it breaks, but it's excellent for surveying the API landscape, especially when it's private. And it works amazing with Atom and Sublime, as I'll show later on. You just dump out the entire hierarchy of the entire system libraries, and you can just instantly quick open headers. It's the coolest thing. And these headers are not the ones that are stripped down by Apple. You get access to everything. Hopper DISASSEMBLER is one of the things that spits out everything that Class Dump can't. It spits out the in-betweens. It spits out how the code is actually built. It'll either spit out raw assembly or some really half-baked C code so you can get a general understanding of what it does. It maps out how the branches work, maps out how the program flow works, and allows you to even edit things if you really want to. Now, let's go for a real-life situation. Every year, Apple releases something new. And every year as a developer, you're like, wow, that's a really cool API. I want to adopt that. I want to try it out. It's going to be some new thing. Right now, you guys are probably building apps with Touch ID support. The problem is, you just adapt this API and then ship it so that it's there on day one. You don't have Touch ID, or sorry, you don't have 3D Touch, not Touch ID. That's a problem. So anyways, just taking a side note, Tim Cook holding things is an excellent meme. I've shown this off before, and a lot of people seem to enjoy it. You know, he holds a lot of money from the earnings call. He holds the rose gold iPhone 6s that you're totally all going to buy. He even holds Tim Cook himself. And like I said, along with NSSpain 2015, Tim Cook holding things should be a meme. Or at least a hashtag. So anyways, going back to what I was talking about. New feature comes out, you're like, oh, I need this, I need to implement it, it's so awesome. You adapt it, you ship it, you forgot about step 3. There is no step 3. Because, like I said, we're shipping apps for devices without testing these new features that actually exist. Just to be ready for day one. Remember watchOS 1, how bad that was? It may have seemed like a great event, but I can name off hundreds of developers that went back and rethought their entire architecture of their watchOS 1 app because it felt so wrong on their wrist. Marco Arment's podcast app was an excellent example. He went and revamped the entire thing just by seeing, yeah, this doesn't work on a wrist. My phone app doesn't work on a wrist. This is crazy. We can do better. The way I see it, make features before they exist. Apple unveiled time travel with their new watch. It's a thing. It just requires a bit of guessing. So, make something cool before someone else does. It's a simple idea. But you do this by anticipating newer feature and prototyping possible things. Play with upcoming things. If you don't have them, mimic them. If you can't mimic them, fake them. Get a feel for how they work before you just throw it in there and hope that it feels awesome on day one. How? A little bit of private API. A little bit more private API. Just a bit more private API. And really, if you look into it, 3D Touch was leaked like 3 builds early. And if you would have known about that, your entire developer cycle could have turned from 2 weeks rushing at the end of the days as soon as you had your GM SDK to 2 months in advance. And I wasn't kidding about it leaking. Like, if you just look, there's a method here that says enable deep press. That's very, very, very similar to the new MacBooks that I'm actually using one right now, where it has the force press, where you can get these extra actions. And this enable deep press happens on UI text fields, in this case. When you're selecting things, you can get like dictionary definitions and things like that. So private API, what is it? Well, it's stuff that Apple typically doesn't want you to use or see. Don't use it publicly. Unless you're a ninja, but don't use it publicly. And it's usually prefixed with underscores. I mean, like, lots of underscores. I mean, this one's a little bit more close to home. That's shown up a little more publicly. Do not use or you'll be fired. It's a pretty cool method name. But anyways, that's a general indication of something either you shouldn't touch or they don't want you to see. And it usually involves unreleased features. It's excellent for prototyping, getting ahead of the curve. I'm going to use that buzzword a bunch. Experimental things. Basically, the entire jailbreak community that was mentioned earlier, we pride ourselves on messing with these internal features and trying them out. even creating new ones that end up shipping in iOS itself. For example, Ryan Petra, good friend of mine, he shipped VideoPane, which is an excellent way to have videos like anywhere on your screen. Apple shipped this in iOS 9 as like part of their side view apps that you can have with your new iPad Pro or your new phones and whatnot. Or no, sorry, not on the phones, just on the iPads, and just on the iPad 4 and up. So going back to the private API, don't ship it, ever. Apple can change it at any time, which can lead to app instability, and which makes your users really sad, because it'll crash. Cool, so we'll leave that there. So, how to be a cool prototyping person? Use what you have to fake something you don't. Doesn't matter if it's good, just do it! Now, the indication when you're prototyping these things, you can also mess around with method names. Do whatever you want with them. Make up some crazy names, some stupidly long ones. Apple has loads of private API that are just ridiculous. What is this? Internal update constraints. If needed, accumulating views needed second pass, and views needing baseline update. What a breath. Multi-threading violation. All that is left to us is honor. That sounds like suicide in battle or something. And then AV player layer with player is just, that's a tongue twister. I'm not even going to try with that. So how can we do this? Widgets. They're an excellent example. Android's had this since the very dawn of Android. It's the point. It's meant to be open. You can mess with it. You can do what you want with it. That's not always a good idea, but it's a thing and it exists. So widgets provide convenient access to simple information. As we've already established, Android already has them. But we all really love them on Springboard. And no, I don't mean these notification center widgets where you have to scroll through a list of thousands of them to get access to whatever you want. Apple hasn't given us to them yet. And when I'm thinking of things that actually extend the interface, actually like draw on Springboard itself. Could you imagine if you, like the settings app, when you're installing an update and you see the little gear spinning, what if that gear spun on the home screen just like the clock updates? What if the weather app actually animated itself to see how it would be if the weather changed in the area? It's always sunny, but what if it was raining on the actual weather icon? I mean, this would take a bunch of power, but it would be really interesting to allow us to just specify one image to update the icon dynamically, just like OS X allows you to update the dock. Why not play games everywhere? This was way back when they launched the iOS 9 betas. I was messing around with them, and I just injected Doom into a running VideoPane on top of Springboard. It's not exactly useful, but it's a fun prototype to show off and learn how the API works. Here I'm grabbing the AV player, whatever, and swapping it out with Doom. I'm just rendering it on top of Springboard, and everything's working. And this is not using Jailbreak. It doesn't allow touches. You can still move it around, still watch it, but it's an interesting exercise to practice and see how these things would work. What if you had an app that was floating on top of Springboard that you can always access, sort of like the split panes now? You can prototype that in there, and when it actually, if it ever is released, then you'd already have something ready and know how it works. For example, the app switcher. I'd love if you could have dynamic app switcher icons to indicate status changes and notifications and things that are going on. Here I prototyped a long time ago a dynamic interface for Instagram that would show your feed as you're switching through apps. A blank screenshot with no apps visible, or like the actual like raw state of the app when you launch it, like a default ping, is not very interesting. I don't care about that. I want to get to the apps quick, and if it looks great, that's a bonus. So the app switcher widget, I accomplished this with just UI application. You just spam app screenshot refreshes by tricking it to think it was going into the background. The secret parameter, UI application, automatic snapshot default. I call this method snave snapshot with name. So what happens was when you kick your app to the background, it screenshots the app in its current state, and if it's not launching, it grabs the default ping and uses that. Or a cached copy or something like that. But when you're switching to the switcher, I just spam this with updates as many times as I can and force it to stay in the background. It's not great. It's going to kill the battery really quick, but it works. So on to Springboard widgets. We can't really draw dynamic icons, but there does exist notifications and badges that we can mess with. Let's abuse that a lot. Introducing Fancy Level. It's the greatest app in the App Store. It's going to be awesome. I've always wanted a leveling app, just something that I can use when I'm painting to make sure that I've got things straight on the wall, when I'm mounting, when I'm making furniture straight and level. This platform here isn't very straight, it's kind of slanted, but it's extremely useful, and I don't want to always have to open this app just to get access to it, search through my Springboard to try and find it. If it was just there, then that would be really cool. I mean, there's a billion of them in the App Store, but none of them do this. So let's make one anyways. So we have a few problems with this. Core motion doesn't work in the background. Does anyone know how we could fix this or could suggest that? Good. So, if we check out UIKit and class dump, we'll see a bunch of things. UI application set application badge string. This is not exposed in the public headers, but it also doesn't have an underscore. It's private API, and it's probably not likely to change. I haven't seen it used anywhere publicly yet, but we can still use this to make the icons pseudo-dynamic. Also, going back to the core motion stuff, when you close an application on iOS, it goes to the background, thanks to a little guy called Watchdog D. It's also the thing you have to wrestle on app launch to make sure it doesn't kill your app instantly. And if it's just taking up too much RAM, it'll kill it anyways. So, how do we keep it open forever? Music's a good example. Something like, do we have sound? We don't have sound. Should we do? Oops, I should have tested this. Yeah, I plugged it in. Yeah. No matter. It was going to be a Rickroll. Work? Okay, we'll stop that for now. So, that would be extremely annoying if you were to play a Rickroll in the background, because iOS is going to keep your app running in the background. It's going to think it's a music app like Spotify or something like that. Don't worry, I'm sorry. I won't do that anymore. Anyways, so what we can do is we can play an empty WAV file. A WAV file is a standard uncompressed audio segment. If we just put silence in there, iOS thinks we're playing music. And if we mix it with the background, the only thing we're really doing is just eating a lot of battery power. It's actually a really common hack, and it's been denied multiple times, but it works great for us. So all we do is register for audio playback background mode. Play some music, music keeps the app running in the background, and whenever we get device motion data, just update the badge. Ta-da! So, let's check that out. Okay, so as long as you can see this. Cool. So, here's a fancy leveling app I wrote. It does absolutely nothing, and it's not showing on screen. Cool. So, here it is here. You guys see that? Yep. Okay, cool. Here's a fancy leveling app I wrote. It opens to an absolutely blank screen because it does absolutely nothing. But when you kick back to Springboard, it updates. And you can see as I'm tilting my device, it's still doing it. It's still doing the parallax, but it's actually showing the offset. And this podium here is about 0.2, 0.1, something like that. It's slightly off, but it's slightly straight. And that's just one example of prototypes that you can do. Let's get back to the slides. So, I mentioned earlier about 3D Touch. 3D Touch is this fantastic new way to interface with things. They just announced it, but it's only coming with the iPhone 6S's and 6S Pluses. 6S's. It's pretty cool. Let's fake it. So, by the way, while I was making these slides, I found this Google image for UI Touch, and it's probably like the coolest thing ever, especially because of like this little happy face wrapper emoji MS Paint thing. It's cool. So anyways, UI Touch. For years, it's had this property called pressure, and nobody actually talked about it. It's just been there for years. It doesn't work anymore, but it was a cool thing to mess around with. What we do get right now is UI Touch Major Radius. Now, this is public API, so you can use this in any of your apps, but we're going to abuse it for something other than what it does. Now, Major Radius returns the radius of a touch, 24, 44 pixels, and size of the screen dimensions. So you can get like the basic approximate of how big your finger is when you touch the screen. Fun fact about that pressure thing, it was actually used in GarageBand, and it was actually extremely clever. So they never had screens that could sort of bend or detect this force touch. They would use the microphone to detect how loud the taps were when you're tapping on the drums and stuff like that and playing along with it. It was really interesting. They also used the accelerometer to detect if the iPad would wobble a little bit just when you were tapping the screen really fast. It's clever. But anyway, so for a 3D touch gesture recognizer, what do we have to do? What do we have to think about? Well, when a finger is pushed on the screen, it flattens. When you can do this with your hand right now, you'll see that the tip of your finger will actually flatten, and more of the surface area will be covered. With a larger surface area, that'll result in a larger touch radius. So for example's purposes, let's say that 1.0 is like a normal touch, and anything larger than that is just slightly bigger. So we'll take a percentage of that. The scale is really unbound, and it's just however you decide we work with it. So for example, my hand. 24 pixels wide, about my finger, my index finger, and a normal touch is approximately that much. There's like a median, something like that, offset that you can use to get like the max and min, but for our sake and purposes, it's about 24 pixels. So you press a little bit harder, the touch will grow to 38 pixels, and that's about a 58% increase. So 1.58 would be our touch, like our new depth that we're returning as our pseudo depth and thing. So another thing that comes with 3D Touch is haptic feedback that's launched with the Apple Watch. We can't really replicate it, but we can fake it using haptics. The iPhone has like a vibration sensor. And when you use the standard APIs, you don't exactly get what you want. You have this audio services play alert sound, and this system sound is a vibrate key. But it takes a really long time. It vibrates for a fifth of a second, and that's not quite what a tap is supposed to be. So let's find something else. We could try and use class dump to find it, but these audio services like functions are C functions, and class dump is not going to find those. It's only going to find Objective-C methods and structs. So let's use Hopper. Disassembling auto toolbox gives us something. Audio services play system sound with vibration. Now, you can go through, and I can probably spend 20 minutes explaining all this assembly, but that's going to be really boring. So we're going to skip to the end. Now, this is a method I call PD pseudo 3D touch play tap. And it gives a vibration pattern as an array. When you specify an NS number for a certain state, yes or no, that designates when the vibration pattern will actually turn on. If you go through and disassemble the method on the actual device, you'll see all this. But if you pull the one from the simulator, you won't. And I'll show you how you can get those if you want to check them out. So anyways, and then you specify a dictionary for all the settings. You want the intensity and the vibration pattern. Now, the intensity, I tried tweaking it up. It didn't really do anything, so I'm not sure if it actually works. Maybe it's just 0 to 1, but I didn't read into it that much. And lastly, you pass this N flag for passing in the sounds and whatnot. So this 0xFFF, it just means play nothing. And when you pass in the dictionary, it'll use the vibration settings that we store in that dictionary. Now we can see this work. Also, this is what hackers look like, apparently. So I'll switch over to Xcode. Cool. Now, keep in mind that this is probably the worst code ever written since the dawn of time, but it works. So we're going to switch displays to mirroring. Huh? Oh. There. That works. Cool. Can everyone see that? Slightly illegible. Let's fix that. That better? That's visible. OK, cool. So now, right here, we have our general setup code. We have our tap method. We just expose the C function as you normally would. This is typically how you declare a C function that's linked somewhere else. It's very standard. And we're going to hop down to our touches began, moved, and ended. These are very important things as part of gesture recognizers. And what we're going to first do is we're going to make sure that when you put your touch down, we're not going to try and detect any sort of pans. We're going to set a limit to that. I think mine's set to like 20 or 40 or something like that. 100, okay, whatever. So it's going to detect a pan of 100 pixels. I guess this was for testing. But anyways, and we're going to get the initial touch radius. This is going to be like our standard like stabilizing factor for what the default touch is going to be. Anything larger than that is what's going to be our percentage that we return as part of our depth percentage. So then what we do is we set up an observer. Now, you could totally set up a timer and just poll the touch like every second, and you wanted to see if you can grab the depth from it or the major radius, but that's kind of inefficient. And this is just a simple, stupid like KVO thing, and I remove it, and I just don't care. I'm not going to worry about it failing. But the important thing that we need is this key path from selector. We're going to grab the major radius whenever it changes to update it to try and be as efficient as possible. And what we're going to do is anytime we get this change in touch radius, we're going to say that the gesture recognizer state changed, so the depth changed, because that's what we're looking for. And we're going to turn that in our touches moved and touches ended. So the touches moved, again, I set up this like translation max amount. It's not going to really work here, but it's just trying to detect and cancel if there's ever a too far a pan that was recognized. So that's all the code for that. And when we actually run, oh, here's the depth code actually. This is just some fudge factor thing that I applied. So on the simulator, you can test it. It's going to set the depth to 1.25 anytime you click down just for testing. But on the actual device, it's going to grab the percentage, the delta, make a percent of that. And then if it's like within like 0.1, because that's kind of like too much, it's just going to not care about it. So hopping over to our view controller, again, this is not properly done. I'm sorry, Andy, for doing this. but whatever. So we're just going to throw our code in the view controller because we don't care. We're just going to create a simple circle. We're going to set up a pop spring animation on that to indicate how much our force is being pushed down on it, and it's going to spring back. And so we're going to get some visual feedback on how much the touches are being pressed. So this is an iPhone currently running 8.4, and we're going to run this on it. Cool. So we should have a little purple icon that appears. Cool. And when I tap on it, just with a simple little tap, it's going to move down and pop. But if I press and then add some more pressure, it's going to recess. Actually, and it's really hard to show on here, but when it recesses that point to the point where I'm just like pressing a bunch, it actually vibrates a tiny, tiny, tiny little amount on here. And that's because as soon as the recognizer recognizes that its depth has changed to about 1.2, anything past that, it'll play the tapsticks just once to indicate that you've sort of like slammed into the bottom of the device when you're doing that force touch. And yeah, that's basically how it works. It's very simple code. It's pretty reusable. But again, it's just a prototype. So now you can add this to all your interface elements if you really wanted to. I'll post the code on GitHub if you really want to try it out. It's not that well written. I don't really care about it. But it'd be excellent to test out just in like, you can even like do some swizzling stuff and like hook it into like UI controls. So all UI controls from that point on will actually have the force touch ability. So if you type new, you can add like an actual popover to it or something like that. It won't work in Springboard, but it'll work in your own apps, which is excellent for testing. So, hopping back. In summary, do, and please do, explore private API when you can. Abuse it when you can. Use it for your own personal purposes, but don't ship it publicly. You will A, get denied. If you hide it and it crashes your app sometime in the future, you're held liable for instabilities. But please do use it for prototyping because it's way more awesome. You can act ahead of the curve. You can make cool stuff. And just remember, a smile is a curve that sets everything straight. Thanks. Any questions? Yep.
Hey, great talk.
Thank you.
I want to ask, you mentioned you were going to explain how to disassemble a framework.
Oh, yes. The device, I'm sorry.
Yeah.
I can do that right now. Also, some of my Canadian leaked out. So we're going to open Hopper. Now, an excellent thing that I love to do is to abuse the Finder sidebar to directly link into the actual like iPhone simulator and watch simulator SDKs. These are typically Intel, so they're easier to decrypt or to dump, and you get like typically better output. But you can totally do it from the device if you pull it off the device or some ISPW or something like that. So we're going to hop into System, Library. We're going to grab. I picked the iPhone simulator, right? Yeah. We're going to grab the Audio Toolbox, which is the kit that contains the audio services. So under Frameworks. Audio Toolbox, cool. And you just open the binary as normal. So Audio Toolbox here. That's not what we want. Oops. There we go. Cool. It's going to decrypt it. It's going to parse everything, show us what's going on. Cool. And here we have a readout. I don't know if you can see on that screen. I don't think you can. Let's change this to that. And change this to 18. Cool. So, as you can see progress up here, it's going through and ripping everything apart, figuring out where everything is. This is some nonsense for load commands. We'll probably get into that tomorrow for the watch stuff, but we don't need to worry about that right now. What we are going to look at is here's all the labels for all the functions that are available. It's going to pull out the C++ ones, the C ones, the Objective-C ones. You can just search for them and find whatever you want. So ours was under audio services. So we can look at that. Play system sound with options, play alert sound with completion, like a bunch of them here. And they're all decompiled so you can see what they are. Now, a bunch of these are going to be knopped out, not meaning it's not going to do anything because it's on the simulator, and the simulator doesn't really do any haptics or anything like that. So you'd have to actually pull the binaries off the device, with which you need a jailbroken device, and that's kind of under the scope of this talk right now. But yeah, that's checking it out. Now, when I said it did like sort of this like pseudo C like fixing thing, where it'll just like spit out C, it'll decompile and spit out like a pseudo version of a C code. Sometimes it's compilable, sometimes it's really broken. You can see this thing barely does anything except return a register and call something else. So that's all it is there. But it's excellent for like more complex functions when you just get a quick overview and then dive right into the assembly and see how everything works from there.
So, great talk.
Thank you.
Not going to bring you a cup of tea. for someone who's starting with hacking and prototyping with hacks, where would you recommend for that person to go once he has something, once he or she has something to show?
So it's interesting, and the only way I can really think about it is how I started out. I started doing Cydia apps like way back when, like I think I did Cydia apps before the actual SDK was out. Like that was iOS 2.0. And from that point, by going through like there's sites online you can go to, like the iPhone Wiki and the iPhone Dev Wiki and stuff like that document how the internals of iOS works. There's also some places where you can see how like the jailbreak tweaks and stuff like that are made, which are like the most common things you find on Cydia. And those are what hook into things and change things at runtime and make methods and other things do other things or extend things. And from that point, there's loads of tutorials how you can learn. Theos is a great example. Ryan, it hasn't been updated recently, but the best way to learn anything really with this sort of thing, it's all sort of self-taught. So it's just to dive in head first and see what you can find. Starting out with class dump and just getting used to command line utilities is a great way. And then from that point, you can start learning how assembly works. Start on maybe some of the smaller and easier like CPUs, like 8082 or 8085 or something like that. That's what I started out in school. And then from that point, you can move yourself up to ARM or Intel or whatever you want to do from that point. Thank you.